In figure given, two springs are set in series combination. So we have two springs in series combination. A, is there any difference of force acting in upper and lower springs? B, find the value of K in series combination. C, time period of the combination. So we have two spring, okay? One upper spring and another lower spring, okay? They are connected in series combination. So we have this, and K1, this is spring constant or force constant, okay? So I'm writing in this way. This is force constant, okay, for upper spring, and Y1, okay, this is the extension, okay? This is the extension or elongation produced in the upper spring, and K2, this is force constant, or this is spring constant for lower spring, okay, and Y2 is the extension produced, okay, this is extension produced in the lower spring, and we have mass M attached at the lower end of the series combination, and we have force F acting vertically downward, okay, as shown in the diagram. So what we find, force F, okay, this equals weight, and we know weight is mg. So this force or weight is also called, okay, it is also called load, okay. So this is load. So let me write over here. This is also called load, okay, acting on the series combination, and F1 and F2, okay, are the restoring force acting on upper and lower spring. So we have this, okay. So what is F1? This is restoring force, and F2 is restoring force, okay. So we have this. Now for series combination of spring, okay, so I'm writing over here. For, let's understand some basic fact, okay, for series combination of spring, okay. For series combination of spring, okay, with load attached at its lower end, okay, each spring is subjected to same load or weight, okay. We have weight mg, weight. Next, total extension is the sum of extension produced in each spring. So using these two facts for series combination of springs, we are going to explain A and find the value of K and time period and this question, okay. And we are asked to find K in series, okay. So this is what K, this is force constant for series combination, okay. Or let me write in this way over here. So this is force constant or spring constant for the series combination. So I'm writing in this way for the combination. So let me write in more clearly, okay? For the series combination. So we have this. Clear? Now let us understand A. Is there any difference of force acting in upper and lower spring? Now since we know each spring is subjected to the same load or weight. So we have load F equals mg or weight equals mg, so that the upper and lower spring, okay, they are subjected to the same load. Therefore, the restoring force F1 equals to F2 and is equal to the load F, okay, in this case. So I'm writing when the weight, okay, we have weight mg is attached, okay, to the series combination, is attached to the series combination in spring, okay, the restoring force in each spring will be same. So we are asked, is there any difference of force acting in upper and lower spring? So there is no difference in force acting on upper and lower spring. So for that reason, the restoring force F1 equals to the restoring force F2. So we are using this fact, each spring is subjected to the same load or weight. So upper and lower spring are subjected to same load, that is F equals mg. So for that reason, okay, we have this F1 equals F2 equals F. So we have this. Therefore, we can conclude, okay, that is, there is no difference of force acting in upper and lower springs. So we have this. Now, B. Find the value of K in series combination, okay? And we know the spring, that is upper and lower spring, are extended by y1 and y2. So let me write in this way. Let y, this is total extension, okay? This is total extension. Therefore, what we get? Y equals y1 plus y2. So we have this, and we are going to use this concept, okay? So let me write over here. We know restoring force in a spring equals minus K times Y. So we have this, Y is the extension produced, okay? And K is the force constant, and in this relation, F is the restoring force. So we can write in this way, Y equals F by K. So I'm writing in magnitude, okay? So this is in magnitude. So we have this in magnitude, and we know force is mg or weight, okay? We can replace force by mg when we have mass M attached at the lower end of the spring having spring constant K. So we have force F equals weight equals mg. So we have this y equals mg by K. So we are going to use this concept in this relation, okay? So y is mg by K, okay? So we know K is the force constant for the series combination, and we know each spring is subjected to same load, okay? So y1 is mg by k1 plus y2 is mg by k2. So we have this, okay? Therefore, after simplifying, okay, we can write k equals 1 by k1 plus 1 by k2. So we can write in this way, okay? Therefore, k equals k1, k2 by k1 plus k2. So we have this. Clear? We have this. So this is the value of k, okay, in series combination. So we have this. Clear? Now, next we are asked to find time period of the combination, okay? So we know for mass spring system, okay, we have T time period, okay? This is what? Time period. This is time period. T equals twice by under root m by k. So we have this, okay? Now, we are asked to find time period of the combination. So we can write in this way. T equals twice by under root m, okay? And we know for combination, okay, the value of k is this. So k is k1, k2, let me write in this way, okay, by k1 plus k2. So we have this. So we can write in this way, okay, twice by under root k1 plus k2 times m by k1 k2. Therefore, we can write time period of the combination, okay? So let me write over here. Time period of combination T equals twice by under root k1 plus k2 times m divided by k1 k2. So we have this. Okay.